Hello Year 12 and welcome to our next video here on trigonometry. We're looking at the cosine rule today, just as we were in our previous exercise, but today we will be using it to find an angle. Now, just a quick reminder of our last exercise. When we used the cosine rule to find the length of a side, the information that we began with were two sides of a triangle and the included angle. That's the angle between those two sides, right? And using that information, two sides and the angle in between them, we found the length of the side opposite that angle. Now today, we're going to take all three sides of a triangle to calculate an angle. Okay, now that's got some pretty handy applications because you can quite reasonably measure the lengths of things, right? You've got a fair bit of equipment that can do that, a ruler or a tape measure or something. Measuring angles, typically a lot more difficult. So if you can measure the lengths of the sides, you could calculate the size of the interior angles, which is what we'll do. Now we still need to remember this relationship with the cosine rule, that there are sort of two sides with an included angle and an opposite side. The two sides that are sort of paired up together with an angle in between them, we're going to continue to label those A and B. The angle between them will be a capital C, uppercase C, and the opposite side will be a lowercase c. So the angle that we're going to find will be the angle opposite C, right? Opposite lowercase c. Keep that in mind. Now, here is an example. I have a triangle, ABC. I have the lengths of all three sides, 3, 4, and 6. And there is an angle here, labelled with an uppercase C, that is opposite the 3 centimetres, that is adjacent to the 4 and 6. And we want to find the size of that angle to the nearest degree. Now, cosine rule, c squared equals a squared plus b squared minus 2ab cos c. I can rearrange that, change it around so that cos theta is the subject, and I get a squared plus b squared minus c squared over 2ab. Again, don't get too wrapped up with memorizing that formula. Okay, you can expect to get that on a formula sheet. Okay. But it is important, right, that the a and b in this case are going to be the 4 and 6. 4 and 6, 6 and 4, it doesn't matter. They're squared and added together, and we also divide by twice their product. C, the one that's squared and subtracted, right, and isn't part of the denominator, is the one side that's opposite the angle we're going to find. Rightio. So 3 matches up with this angle here. So it's really important you get those in the right spot. Now, substituting into that, A is going to be 4 or 6, and then B will be 6 or 4. C is definitely going to be 3. Right, so substituting in there, I get 6 squared plus 4 squared minus 3 squared over 2 by 4 by 6. Now, 6 squared plus 4 squared minus 3 squared is, I think it's 43. And 2 by 4 by 6 is definitely 48. So theta, right, remember when we're finding an angle we use the inverse function. So it's the inverse cos of this expression here, which I've simplified to 43 on 48. And when I type that into my calculator, to the nearest degree, as requested, it's 26 degrees. So make sure that what's written down here matches what's in the diagram, right, that you could repeat that you can enter that into your calculator and get the same result. If you've got any questions, and that's pretty reasonable if you do, make sure you write them down so you don't forget them, and so you can ask me next time we're talking, hopefully in our next class meeting. Rightio. Well, that's it for the cosine rule. Just a little recap here. If we have 3 sides of a triangle, we can use the cosine rule to find the interior angles one at a time. And the way we do that is using this version of the formula, right? We rearrange the formula so that cos c is a squared plus b squared minus c squared on 2ab. We will use the inverse cos to find the angle. Rightio. That's it for today. Our next exercise is going to be on the area of a triangle. I promise it's nice and straightforward. Okay, see you in class.